Hey guys, I hope you're all doing really well this week. I was contacted by a subscriber who says he's got one of these. This is a HP Notebook 15 DY1124NR. Now this is a 15.6 inch laptop. It's actually i7. It comes with, well, this is from the page, 12 gigs of RAM somehow. It's got a 4 gig and a 8 gig. I don't know who is. Maybe they ran short of 8 gigs or something like that, but it comes with 12 gigs of RAM, a 512 gig SSD hard drive, and the issue he said he has with this is that it's not booting. So I don't have any laptops to fix this week. All I get in is broken screens and broken hinges anymore. I don't really get anything interesting, so this sounded like it might be something interesting. So I said I'd go and try and source a good picture of the motherboard and a schematic for it, and I'm going to run through the input section on this, and I've asked him to send me an image of the motherboard, and we're going to take a look at it then and see how we can get it back working again. Okay, so even without having the board here, I was fortunate enough to be able to get a reasonably good image of the board. It's not as good as the scan ones I can do myself, but it's workable, and we were able to find a schematic. So I'm going to jump right in here. This is the motherboard. As you can see, it's a very unusual sort of shape. You know, the fan sits in there, so obviously there's a big gap here, but where do we even start with this? Well, it's the same as usual. We go right for DC input. So I don't see any input jacks along here. That's just USB. I don't know what the hell that is. Type C, is it? But if you look down at the bottom here, there is an 8-pin connector. So let's zoom into 100%. So this connector here looks like our DC jack. So how do we find out which is our ground and which is our positive? And I'm presuming there's some sort of sense pin on this as well. Well, I have the schematic here, and I've gone to the section where it shows where the DC jack comes in. So there's a 45 watt to 90 watt adapter. There's our DC jack. It's CN1001. You will notice on this motherboard there are no markings. So how do I know that this is the same one? How do I know it's the right schematic? Well, what you can do is you can look at these, and first of all, it's got 8 pins on it, so that's a good start. So we've 1, 2, 3, 4, 5, 6, 7, 8. I'm going to mark those 8 pins in. So as you can see, we've got 8 pins on it, and if you look in, I sort of lose definition with this picture as I zoom in, but I'm just going to do it here just so we can close in a small bit. As you see it here, 1 and 2 are together. So as you can see here, pins 1 and 2 are together. And if you look here, 3, 4 and 5 are together, and they're going to ground by the look of it. So that's 3, 4 and 5 are together. So that seems to be the same as our board here. This, I think this AD-ID here, this number 6, I think this is what this is here, AD-ID, that must be the pin. Oh yeah, and we've got 7 goes to LED 1 and 8 goes to LED 2. So as you can see here, 7 goes to its own pin here, and 8 goes off here. So it looks like this is a fairly accurate representation. The pins are certainly the same anyway, in that 1 and 2 are grouped together, and that is our positive rail. That's where our positive voltage comes in. 3, 4 and 5 are also together, and they are our grounds. And then the other pins have just other functions, but the ones that we really want to be concerned with when we're checking the input section are our positive rail, which comes in the 2 here, and we have our ground here. So let's get a look and move inward. Now, I checked online, and on Charger Buy, you'll never guess what they sell, you can get a replacement charger for HP 15 DY1124NR laptop, and they say that it is a 19.5 volts 2.31 amp. So my point in that is that we should be expecting 19.5 volts coming in here. So the first thing you would be checking on this, of course, is you would get your multimeter and just check for 19 volts at this point. But what we're going to follow along here is our 19.5 volts. Where does it go? When we follow along, you can see here that pins 1 and 2, which is the positive voltage coming in, it first of all is meant to go to PL1001 and PL1002, which, you know, L is usually for an inductor, P is for power, so power inductor. However, as we said before, there's no markings on this, and they don't exist. But I think this is the spot here where they may be put on some configurations, but they're not put on this one. So we are going straight across this path here and onto this, which looks like a diode right here. So I presume that corresponds to this. Again, we've no markings, but you know what? Sometimes it's better not to have any markings because it gets you more used to doing it yourself without, you know, being spoon-fed all of the information. So what is this? This is a diode. Looks like some sort of Zener diode or TVS diode. It's a ZVS by the look of it here. So let's find out what this is. PD is power diode 1002. But let's see what the model number of it is here, just to be comprehensive. I found this data sheet for the P4 SMAFJ series of diodes. So what it describes this as is a surface mount transient voltage suppressor, or TVS, diode. So this is meant to save your laptop if the voltage goes too high. So let's just see. Okay, the one we're looking for is P4 SMAFJ20A. So what does it say about that? Reverse standoff voltage is 20 volts. The breakdown voltage is 22.2 volts. And remember, that's with an adapter of 19.5 volts. So that should start conducting to ground at 22.2 volts, I think. So that's in order to save the laptop, because you don't want high voltages going past that. You don't want high voltage going past this point here and in and possibly causing other damage. Now, I have seen other people complain that, you know, what's the point in having a diode here like that, because if it goes short, your laptop won't come on anyway. But they still seem to use them on quite a few of these laptops. But that's what that is for. So we're going to move on next. So we're coming through here and onto our first MOSFET. So let's take it from there. Okay, so back on our split screen, I've just drawn in where the 19.5 volts is going. Okay, so if you want to follow the two of them along at the same time, we've pins 1 and 2 here, which is where the 19.5 volts comes in from the adapter. That goes along here through where there is two markings for two inductors, which correspond to PL101 and 1002, but they don't actually exist in this configuration. So we're straight past those on across the diode, which is here, and then on to the 4 pins of this MOSFET. Now there's two MOSFETs here as usual. This is an AC FET and this is an RB FET. The AC FET is for controlling the voltage coming into the system, and the RB FET is to prevent any of the battery voltage from entering this part of the circuit when the laptop is plugged out. So what is the story with the two of these? Well, we can search for the schematic for each one. Usually there's N-channel MOSFETs that are about 30 volts in both of these positions, or sometimes there can be P-channel MOSFETs, but let's have a look and just see what they are quickly. Okay, so our AC FET is an EMB02N03HR, which is an N-channel logic level enhancement mode field effect transistor, 30 volt. As you can see, the 4 drain pins are together on one side, you have 3 source pins together on the other side, and a gate. If you've looked at my videos before, this is a very, very common configuration. So this is an N-channel MOSFET, so this is turned on when our gate pin is high. The other MOSFET in the RB FET position is an Aeon 7408. The fact that there's an even number at the end means it's an N channel also. It's also a 30 volt MOSFET, and once again our 4 drain pins are together on one side, 3 source pins and our gate pin are on the other side. And if the gate pin is high, this is switched on as well. If we go back to our schematic, you'll see that the 2 gates for the 2 of these MOSFETs, here and here, are controlled by the BQ AC drive pin of our PU1001, which is in fact our battery management IC. So when our battery management IC sends the appropriate voltage out to these pins, it hits both of these gates and turns the MOSFETs on. So the question is, without having a motherboard in front of me, what voltages should I be expecting to see on the input section of this board? Well, we know we've obviously got 19.5 volts here, right? So that's coming along here, and we should be measuring 19.5 volts at the input of the first MOSFET. Now, the MOSFET needs to be switched on in order for that 19.5 volts to come through the AC FET here. So to switch that on, usually the gate voltage from the battery management IC is something like 23 or 24 volts. So when I measure the gate pin of this, which is right here, I should expect to find approximately 23, 24 volts on the gate pin. And with that voltage on the gate pin, this turns this MOSFET on, and our 19.5 volt comes through from our drain to our source. So we should also measure 19.5 volts here, and that corresponds to this point right here. So if we find that there's 19.5 volts here, we then just need to make sure that our 19.5 volts is getting through our second MOSFET, which is our RB FET, which corresponds to this MOSFET right here. So we'll know that the gate pin is going to be the same for both because it comes from the same source. So you would expect to find the same 23 or 24 volts on the gate pin of the second MOSFET, and for this to be switched on. And when this is switched on, it allows the 19.5 volts from here to pass through to this section here, which it refers to as PRWSRC. I've marked with a red line right here where our 19.5 volts would be expected to come out of the second MOSFET, and then it lands on our current sense resistor. It goes on a second path across here, but it goes down to PR1001, which is a 0.01 ohm resistor. That corresponds to this current sense resistor here. Apologies, it didn't come out as well as I thought it would. But this is our current sense resistor here, and after this point, this is our main voltage rail. Okay, so this is our main voltage rail right here. So with that analysis of the input section done, I decided to get a look at the images that were sent to me by my subscriber and see if we could help. So let's get a look at those images. Now, before I go any further, I want to give a big shout out to Dana Ray Poole, who's a subscriber to the channel. He took the time to send me quite a few images of this so that I could get the serial number and get proper images of, the original image of the laptop and a proper specs. He sent me close-up images of the MOSFETs and different components so that I could make sure they were the same as the schematic, and other images that helped me to make this video. So this is the back of the laptop, and the other image that he sent me was this. As you can see, it's in very, very good condition, but it's not powering on because there is some sort of fault with it. So the one image that is most relevant to this is this one right here. Now, you should recognize this from the start of the video because this is the same motherboard, but this is the motherboard that he took out of his laptop. As you can see, we have our 8-pin connector that connects to the board here. So we've 1, 2, which is our positive. You can see the red wire here. We've the next 3. Actually, the third, number 5 is left empty for some reason, but we've got 2 grounds here that come to these, and then it was our ID, LED1 and LED2. But this is the path, as you can see, across our TVS diode to our first MOSFET, to our second MOSFET, and onto our current sense resistor, and here is our main power rail. Now, when I got this picture and looked at it at this level of zoom, I was able to spot what the fault was. So what I'm going to do is I'm going to put this challenge to you to see if you can work out yourself where is the fault. It might seem like it's a ridiculous thing to be able to do, but it is actually possible to see the fault on this. And what I'm going to do is I'm going to leave that as a challenge there. You guys can post down in the comments below, and what I'll do is I'll put an update in the pinned comment underneath below to give the answer. So I'm going to leave that with you guys. Thanks for watching, and we'll have something good again next week. And make sure to post your answers down below. You need to be learning something on this, and I think it should be possible to get the answer right. Have a good week.